Happy Wednesday. Today's goal is that you can write exponential functions from a table, 2 points, and from a graph. So grab a copy of your note sheet and let's get started. So exponential functions you need to be able to write just like you could write linear equations in all different forms. You could write in standard form, slope-intercept form, point-slope form. We're going to be writing exponential functions in the form y equals a b to the x power. So our y is still our output, our x is our exponent. A, if you remember from what we've done on Monday, a is always your y-intercept. And the b is the growth or decay factor. It's the factor that you increase or decrease by each time you move along on x. So from a table, this is going to be pretty easy. We're going to be looking for our y-intercept. Sometimes the table will have it listed right for you. In this one, it does. The y-intercept is 5. That's what y is when x is 0. So we know that the equation is going to start off y equals 5. Now we're looking for our factor. We're looking for what gets multiplied by each time you move along in x. So it went from 5 to 15 to 45. It was constantly being multiplied by 3. So that is the factor. So this is our function for that table. For the second table, again, the y-intercept is given to us right there. So we know that it's going to start off y equals 9. And then in parentheses, again, our factor is 3. It was multiplied by 3 each time. So that goes in the parentheses. If you look at the example that was done out for you, the y-intercept was 10. And each time it went along in x, it was multiplied by 5. We can tell that this table is not going to be linear because every time it goes up 1 on x, it gets multiplied by something on y. It doesn't have a common sum, it has a common factor. Right. Now writing from 2 points, this explains it, but I'm going to skip that part. You can have that to reference if you want to, and we're going to do the examples out together, but that'll be another reference for you. So if we want to write the exponential function that goes through these 2 points, again, we're thinking y equals abx. A is our y-intercept, b is the factor. So to find the equation from 2 points, I'm going to start by substituting the y's and x's in that we're given. And I'm always going to start with the largest x because I want my largest exponent to be written first. So I'm going to start with this point. So I'm going to put 12 in for y, and that has to equal a times b to the 3rd power. Now I'm going to substitute in the other set of points. So 3 has to equal a times b to the 1st power. These 2 equations I'm going to divide. You can add, subtract, multiply, divide equations, and the new equation that you get is also a true equation. So I'm going to divide these equations. So I'm going to make it a fraction. So on this side I'm going to do 12 divided by 3 and get 4. My a's cancel out because a divided by a is just 1. And now here, if I have b to the 3rd power divided by b to the 1st power, if you remember with exponents, if the base is the same, you subtract the powers. So I'm going to get b to the 2nd power. If I know that b to the 2nd equals 4, and I square root each side, I know that b has to equal 2. So now I'm partway done. I have my b. Now I need to figure out my a. So to do this, I'm going to use that information and plug in again. And this time, I'm going to substitute my b for 2. So I'm going to take either point, and for this one, I'll use my smaller numbers. So when y is 3, a times 2 to the first power is what that equals. So I'm going to do 2 to the first power and get 2. 2 times a has to equal 3. If I divide by 2, I know that my a has to equal, divide by 2, I know that my a has to equal 1.5. So now that I have both my a and my b, I can rewrite the equation so I have it written out nicely. Y equals 1.5, in parentheses, the 2 to the x power. Now for the second one, I'm going to do the same thing. I'm going to look to see which one is my highest x so I can put that on top so that when I subtract my powers, I get a positive power. It will work if you get a negative power and put the other number on top, but it's much easier to deal with the positive powers. So I am going to put this one on top because it's my largest x. So I'm going to put 1 in for y, a times b to the 4th power. And now I'm going to go to my other point and substitute that in. 4 equals a times b to the 2nd power. I'm going to divide these two. 1 divided by 4 is 1/4. A divided by a, the a's cancel out. B to the 4th divided by b to the 2nd is b to the 2nd. And now I want to do the square root of both. Square root of fraction is like the square root of the numerator over the square root of the denominator, right? So this would equal 1/2. So my b is going to be 1/2. So now I'm going to take either point, and I'm going to take my smaller point. And I know that 1 has to equal a times b. My b is 1/2. So a times 1/2 to the 4th power. 1/2 to the 4th power is 1/2 times 1/2 times 1/2 times 1/2, which would be 1/16. Times a has to equal 1. So that means a has to equal 16. And if I plug that into my equation, I get y equals 16, in parentheses 1/2 to the x power. And I can check this with my other point. I can do 1/2 squared, which would be 1/4, times 16 would give me 4. Now you want to be able to write an exponential function from a graph. So if we can scroll this up, there we go. So from a graph, you're looking for the two things, your a and your b. Your a is probably the easiest one to identify on your graph. Your a is your y-intercept. So here the y-intercept looks to be 1. So y equals 1 times. Now I want to know the growth factor. So I want to go over 1 on my x-axis and see where the graph crosses. And it looks like it crosses at about 5. It's a little hard to tell on this graph. We would identify the points for you on a test or a quiz. We would write in what that location was so you wouldn't have to estimate or guess. It appears to be at 5. So that's the b number, because that's what 1 was multiplied by 5 to get to 5x. Now this 1 doesn't actually have to be there because it doesn't change the equation, so you can write y equals 5 to the x power. For this next one, again, I'm looking for my y-intercept, which again appears to be 1. So I'm going to have y equals 1 And now I want to see what it crosses at for 1 on the x-axis, and it appears to cross at 2.5. Again, these would be labeled for you if this was a test or a quiz. Now this 1 isn't important, it doesn't need to be written there. So you can have y equals 2.5 to the x power. Then the last thing, if you can write equations from a graph, you can graph an equation. So if you scroll, alright, so for these ones, we're looking at what information we're given and we want to make a graph that represents this. And these are sketches. They're not going to be as exact as we could with a linear equation. So the easiest thing to identify is our y-intercept. So on this first one, our y-intercept is 3. Our b is 4, so I know the graph is going to be going up, and it's going to stay in these 2 quadrants because it's going to come very close to the x-axis but never touch it. Now, if I go over 1, I should multiply by 4 to get my next number. So if I was at 3 and I go over 1, I should be at 12, but there's no 12 on the graph. So instead of going over to the right, I'm going to go over to the left. So instead of multiplying by 4, I should divide by 4, which would make 3 divided by 4 is 3/4. So I'm going to put a dot at -1 and then estimate 3/4 and sketch from there. So this would be very steep at this point. For this next one, my y-intercept is 1/4, so I'm going to put a dot estimating where 1/4 is. My factor is 4, so that means it's growing. So it starts at 1/4, and when I go over 1, I multiply by 4 and get 1. Then I multiply by 4 again, and I get 4. So I can have that as my sketch. You do want to put arrowheads at both ends of the graph. And for our final one, this one doesn't appear to have an A, but you want to separate these 2 parts because the x is only attached to the 4 because the negative isn't in parentheses. So this is the same thing as having y equals -1 parentheses 4 to the x power. So I'm going to put my first dot at -1. And then I'm going to multiply by 4. So if I go over 1, I'm going to go down to -4 for my next dot. I could go back to -1/4. So this graph would cross through quadrants 3 and 4 and look like that. Now you'll go to Flipgrids and do practice problems for any type of problem you think you still need more practice with, and let me know if you're stuck. Have a good day.